Hello, quick video on solving quadratic equations using factorising. I'm going to demonstrate 3 or 4 equations here where we've got the equation. We're going to work out what factorised form of that equation is, and then we're going to find the solutions, often called roots as well. Okay, 3 of these are more straightforward and we'll work our ways through and build up in complexity, and then there's one much more difficult one here at the end that if you don't want to watch, don't watch. Okay, let's do the first one then, and we'll go through the principles. So let's have a look at this expression: x squared plus 4x plus 3 equal, and we're going to set that to 0. Well, if we knew what was in our bracket, the 2 numbers that were in our brackets here, we would know that if we multiplied them together, we're going to get our unit value. So we're looking for 2 numbers that multiplied together are equal 3. And if we look here at the coefficient of our x, we can see that our 2 numbers would be added together. So we need 2 numbers that added together are going to equal 4. There we go. So what we can do now is just make up a list of options of integers where we've got those factors. So 2 numbers that multiply out to 3, integers are 1 and 3, and if we add those together we get 4, which is what we're looking for. Just to bear in mind, there's also another potential option, minus 3 and minus 4, so when they're multiplied together we get our 3, don't we? But when we add them we get minus 4, which is not what we're looking for. So here we had 2 options and we found the one we're looking for here, so our numbers are 1 and 3. So we can rewrite this expression here as 2 brackets, x plus 1 times x plus 3. And the fact they're multiplied together is important because 2 numbers when multiplied together that come to 0 means either the first number is 0 or the second number is 0. So it's either 0 times 6 or 5 times 0, isn't it? So one of these brackets has got to be 0. So either the first bracket there, the x plus 1 is 0, in which case x equals minus 1, or the x plus 3 is 0, so the value of x is minus 3. So there you go, that's the principle of what we're doing, isn't it? We're going to find 2 numbers that multiply together to be the units value, and we're going to find 2 numbers that when added together, then we're going to check which of those numbers when it pairs, when added together, will give us our coefficient of the x value. Then we're going to turn it into the brackets, and then we're going to find when each of the brackets is 0, and they're called the roots. There we are. So let's try a second example. X squared plus 7x equals plus 12 equals 0. So here the 2 numbers multiplied together must equal 12, and the 2 numbers added together must equal 7. So let's try some pairs and try and put them in a sequence. So I usually start off with a equals 1, so b would have to be 12, the second number. The other ones are 2 and 6, and then we've got 3 and 4. Okay, so there are our options. So 1 and 12, well, that adds up to 13. That's not what we're looking for. 2 and 6 are 8. That's not what we're looking for. But 3 and 7 come to 4, which is what we're looking for. So those are our correct answers, 3 and 4. So we can rewrite the expression as x plus 3 is one bracket times x plus 4 is the other bracket. So when the first bracket is 0, then x must equal minus 3, and when the second bracket is 0, x must equal minus 4. So again, that was pretty straightforward, wasn't it? No, I didn't bother to look at any negative values here because both of my numbers coefficients are positive. But have a look at this one. What are we going to do when one of them is positive and one is negative? So let's have a look at this up here. X squared plus x minus 20 is going to be equal to 0. So a times b, the 2 numbers multiplied together is minus 20. 2 numbers added together is plus 1. So again, let's start making up pairs that come out to minus 20. Multiply out to minus 20, so I've got 1 and minus 20, I've got 2 and minus 10, I've got 4 and minus 5, I've got minus 1 and 20, minus 2 and 10, minus 4 and 5, and they're the only integer pairs that I've got can use. So there works the complete set of options. So 1, now we've got to add them together, haven't we, and see which is the right pair. So 1 take away 20 is minus 19. That's not what we're looking for. Next one's minus 8. No. Next one's minus 1. No. The next one is plus 19. No. And the next one is plus 8. So the only one that gives us plus 1 is this last pair. Minus 4 and 5, when added together, give us plus 1. So that's what we're looking for, isn't it? That means we can rewrite our expression there with bracket, in terms of brackets, x minus 4 times second bracket x plus 5. So when the first bracket is 0, x must equal 4, and when the second bracket is 0, x must equal minus 5. So there we go. That's a pretty straightforward process. If you're confident with that, call it a day at this point. Don't bother to watch the rest of the video if that's all you want out of it. If you want to do a more complicated one, let's have a look at this final option. So expression now is 2x squared plus 13x plus 15 we're going to set that, it must equal 0. So that means we've got to have much more complicated brackets. So we've got a number now, an integer in front of our x, and as well as an integer in the bracket afterwards. And again, we're going to have an integer in front of our second x in the second bracket and an integer in the second bracket. So px plus a and qx plus b. Now if we multiply those out, we can see that our coefficient, the number in front of our x squared, has got to be these two numbers p and q multiplied together. At the other end, looking at our units, we're back to what we saw before, which is a plus b multiplied together will give us our unit. So this bit's the same, isn't it? So here a plus b would have to be 15, but our p and q here have got to be 2. Now the important thing is how we rewrite our method to make this work. So if we have a look at this middle bracket here, we've got qa, and the other one we've got pb. So these are going to become our pairs, because if we look at it, if we multiply those two together, qa times pb, actually that's the same as multiplying pq, that number there, for our x squared coefficient and our units coefficient, which is AB. These are just in a different order, aren't they? QAPB is the same as PQAB. And that's how we're going to get around this problem, because we're going to work in those pairs. We're going to look at PB and QA as being our two pairs. In order to solve it, the first thing we need to do is to multiply our coefficients and the square and the unit together, that are 2 and the 15, to get 30. Now we're going to go looking for pairs of integers that when multiplied together give us 13, and at the same time that's going to be our list of options, and then we're going to look for the one that fits our second criteria, which is when you add them together you're going to get 13. So let's make a list here. Again, going in sequence, we could have a pair of 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay, then we're going to go through our adding up process. So 1 plus 30 gives us 31. Well, that's not the 13 we're looking for, is it? 2 and 5 is 17. Nope. And 5 and 6 is 11. Nope. But 3 and 10 added together give us 13. So that's what we're looking for, isn't it? So we know we're working with 3 and 10. But now we need, so that's the same as we looked at before. Now we've got to break those up and look at what the factors of each of the 3 and 10 are. So let's start with the 3. Well, that's pretty straightforward, because the factors of 3 are only 1 and 3, aren't they? So if we multiplied 1 by 3, we'd have our solutions here. We know what we're doing. Okay, but now let's have a look at the 10. Well, that can be factorized as either 1 and 10 or 2 and 5. So which of those are we going to use? Well, let's go back and have a quick look at our coefficient of our x, which the p and q, which is 2. So we can't have 1 and 1 as being p and q, can we? Because we don't get 2. We can have 1 and 2 as being our p and q. So that means that 1 and 10 doesn't work, but the 2 times 5 does work. So we have to factorize 10 as 2 and 5. and we have to factorise 3 as 1 and 3, and we also, because P and Q equal 2, they must be integers, and we've got to factorise that as 1 and 2, haven't we? P and Q must be 1 and 2. Okay, so now we've got the information we need to get to our next step. So we're going to assume that PB is 1 and 3, and Q in A is going to be 2 and 5. And what we now need to look at is how we split those up. So we know we've got to multiply them together in our calculation, so we've got to put those into different brackets, the 1 and the 3. So the 1 goes into the first bracket as the multiple of x, and the 3 goes into the second bracket as the multiple, or as the units of 3. Here we go. Excuse me, let's just get rid of that symbol out of the way. I don't really want that there. Good. Right, there we are. Okay. Secondly, if we look at our Q and our A, then our Q value is 2, so we're going to put that into the second bracket, and the 5, the multiple, must be going into as the units in the other bracket. So can you see how we split those up to make it work? And now we can see that that our expression can now be split into two brackets, x plus 5 multiplied by 2x plus 3. And just looking at our two solutions, then when the first bracket is 0, x plus 5 is 0, then x must equal minus 5. And the second bracket, and 2x plus 3 equals 0, then x must equal minus 3 over 2. So there we are. Quite a much more complicated method, but it's following the same principles. You've just got to remember this bit about splitting the numbers into the opposite brackets factors. There we go. Okay, so here's our little summary. What we're doing, well, we're finding two numbers when multiplied together give us our units, and when added together give us our x coefficient. We make pairs of them up here, we try all our options, and we see which pair works. In this case it was 3 times 4 is 12, and 3 plus 4 is 7. Tick. So that worked, and there's our right one. We rewrite the expression as two brackets, x plus 3 times x plus 4, and when that's 0, one of those two brackets must be 0. So either the first bracket is 0, in which case x is minus 3, or the second bracket is 0, in which case x is minus 4. If you come across one of these where there's a coefficient in front of the x squared, then you need to multiply your square coefficient with your units, and then carry out the activity we did, looking at the multiplying and the adding, finding two numbers that fit those two, and then you need to split up those pairs into the separate brackets. So there we go. Hope that's of use.